methods, but there are a couple others that you need to know when working with collections. So I've created a package called lesson 4, and we have the application class in which we've defined the main method. And in here, I've defined two array lists. One of them is list1 and the other one is called new list. And they both are capable of storing integers only, as you can see specified in the angle brackets. So list1 has 5 values, new list has just 1 value. If I wanted to merge both of these lists together, I could use a method called ArrayAll. And what I would do is I could do list1.addAll and then specify the collection from which we want to merge the data. The second collection we have here is new list. So this line of code is going to take all the data that's in new list and merge it into list1. Okay, and now just to verify, let's do a sysout to see the data that's in list1, and you'll see that it's going to have the value 10. Let's hit play and notice this new value, the 6th value, has been added. Similar to ArrayAll, there's also a method called removeAll. Let's see what happens when I do removeAll on list1, and I'm giving new list as the argument. So now let's print list1, let's hit play, and notice that list1 has the values that it always had: 12, 43, 15, 67, and 43. List1 didn't have the number 10, but if it did, right, if it did, it would have been removed because we're saying remove all new list. Now let me add a couple of 10s in list1. Hit play and notice none of the 10s make it into the first list because we're doing a remove all and specifying the list that contains the data that needs to be removed from the original list 1. Let's add another number in here that exists in the original list. So for example, 67. Okay, and just to prove a point, I'm going to add another one. Let's also remove 15. So at this point, we have all these numbers in list 1, and we have these 3 numbers in list 2. And I'm going to do list1.remove all new list. So all of the numbers here are going to be removed from the list 1. So let's hit play, and boom, notice that we only have 12, 43, and 43 left. Now if I get rid of the argument, it doesn't work. Remove all takes an argument. So you might be wondering, well, how do I eliminate everything from this list? There's a method called clear, just like that. That does not take an argument, and that's going to eliminate all of the data in the list. So let's hit play and notice that we get an empty square set of brackets. There's no data in list 1 because we called the clear method. Now if we want to check for whether a particular item exists in a given list, I could do contains. So I could do contains and give an argument for the value that I hope list 1 contains. So let's try the number 67, and I'll store that into a Boolean variable because the value that's returned here is going to be of type Boolean. It's a true/false value, whether list 1 contains the number 67 or not. So we'll just say has value, and I can print has value to see what is returned. So right now 67 we know exists in list 1, so I expect the value true to be printed to the screen. So let's hit play and notice that it's giving true. If I give some other number, for example 48, 48 does not exist in list 1. So let's hit play and notice that it's showing false. There's another Boolean method called isEmpty, and this just returns whether the list is empty or not. So let's hit play and notice it's going to say false. The list is not empty. If I was to clear the list first, like we're doing on this line right here, and then do isEmpty, it's going to return true. Let's hit play and notice that it's returning true. So far we got add all, remove all, contains, clear, as well as isEmpty. There's one more I want to go over. It's called RetainAll. RetainAll is used to remove everything except for the values that you'd like to retain. So for example, if I call RetainAll here, I could do list1.retainAll, and then I specify what I want to retain within this list, and that's going to be new list. What's going to happen is it's going to delete everything from list 1 that is not within list within this new list. So it's going to only retain new list values inside of list 1. So I expect everything in list 1 to be deleted except for the number 10, 67, and 15. Let me get rid of this clear line right here. And this does in fact return a Boolean value if something took place. If it does delete things, it's going to return true, otherwise it'll return false. But at this line, we've effectively deleted everything that isn't inside of new list. So let's print out the values of list 1. Let's hit play and notice that only 15, 67, and these 4 10s survived. Everything else was eliminated. Now moving on, if I wanted to convert a hash set into a list, what I could do is, let's first make this a hash set and do the Control-Shift-O to do the import. So we have the hash set class here. If I wanted to convert this, now it's a set. If I wanted to convert this into a list, what I could do is the following. I specify the list interface and give the integer data type. And let's just call this li for the list. And then do new ArrayList and give the integer. And as the argument to the constructor of this ArrayList, I can pass in this hash set. So I do list1 right here. And now what's going to happen is it's going to take this hash set and populate this new ArrayList with that data. Let me do a Control-Shift-O to import the list interface right here, the java.util list. So let's hit finish because we are referencing it right here. There are benefits from converting lists into linked lists or hash sets into lists and so on, back and forth. You can do that, and this is the way to do it. This is the easiest, fastest way of doing it. You just instantiate a new list or new collection, whether it's a hash set or list, and then you specify in the arguments of the constructor the data that you would like this new object to be populated with. So let me get rid of all of this extra stuff. I want to go over sorting data. Okay, if I wanted to sort this collection, let me rename it to something that's more appropriate. Hash set, because this is in fact a hash set. I shouldn't call it a list. So let me rename all of these to hash set. If I wanted to sort this hash set, there's a method called collections dot and then sort. All right, so this method exists on the collection class, and you specify a list as an argument to the sort method. Now the problem is that this is a hash set. Okay, I can't pass in this hash set to this sort method because this collections framework has this method sort. It accepts a list only, as you can see here. This is all going to make more sense when we go into generics deeper. This might look a little intimidating, but trust me, it's not that bad at all. We'll get into the details of all these angle brackets and question mark and these T's and so on. Don't worry. But what I want you to see right now is that notice that the sort method, it accepts a list, and we're passing in a hash set. So there are benefits to converting collections into other types. So let's now convert this hash set into the array list. So let me define a new array list, integer, and I'll call it my list due to the lack of a better name. And it's going to be of type array list with integer data type. And as an argument to this, it's going to take the hash set. Now, obviously, when this code is running, it's going to go line by line, executing each line of code. And when it gets to here, it's going to add the 10, but it's not going to be adding any of these 10s. So let me just get rid of them altogether. We don't even need those. So now this my list is going to contain all of the data that this hash set contains, and I'll be able to sort it. So let's hit play and notice that, well, we haven't printed anything out. So let me sys out the my list collection. Let's hit play and notice that it's sorting it from smallest to largest, 10, 12, 15, 43, 67. Now you might be wondering, how does it handle strings? Well, let's give it a try. Let me change this to the string data type. I'm going to copy and paste that there. And the data that's going to go in here now is going to be words. So let me just put in some random words, starting with the word random. That's our hash set. And I'm going to convert this hash set into a list. So the list data type better be the same as the hash set data type. So over here we have strings, so we have to specify this new list to also be able to contain strings. And now we can convert this hash set into a list. And now if I sort this list, let's hit play, and notice that it's sorting it alphabetically. So from A to Z, you got close, computer, random, and then T is the largest letter, so to speak, in this list of words. And this is referred to as natural order. When you have words like this, when it sorts alphabetically from A to Z, that's the natural order of the string data type. If you have integers, the natural order for integers is 1 to 10 or 1 to 100. But things get a little tricky when you have user-defined types. So for example, if I have a class called employees and I create a couple of instances of employees, let's say I have 10 employees, how would we be able to sort a list of employees? What would that even mean? Would we sort them alphabetically by their name, or would we sort them by their height? Because it's a user-defined type, we have to also specify how we intend on that data type to be sorted. So let's go over how we can do that. Let me create a new class in the same package, lesson 4. Go to new class, and I'll call this employee. And it's going to be a simple class. We'll give a few fields. The employee has a name. He must also have a salary. And just to be fancy, let's give him a department. And now we just needed a constructor. So right click, go to source, generate a constructor using fields. And now, as you're aware, we can create collections with user-defined types. So if I have a hash set here, I could change the data that it takes to be employee. Let me paste that here. And then the data that's going to go into this collection is going to be new employees. So let's just define a few of them. I'm going to do new employee. And then in the constructor, we pass in the name. So let's say first employee is Mike. His salary is $3,500. And he works in the accounting department. I'm just going to copy paste this to save some time. So we got Mike. Let's make Paul, and then Peter, and then finally one more employee. Let's try Angel. So we got 35 for Mike. Let's give Paul 3,000. Just coming up with random salary numbers here. 4,000 and 2,000. And the departments, let's make this admin department. For Peter, he works in IT, and let's make this the maintenance department. So I'm just going to call it maint. Okay, so we have 4 employees, and now to convert this hash set, remember we can't sort it unless it's a list. So let's convert it into a list. So I'm going to, of course, need to change the data type for this to also be employee. So now my list is a list of employees. So now if we try to sort my list, you can already see that there is an error. If you hover your mouse, it's saying that the method sort, and notice the arguments. It accepts a list. So we're fine. This is a list. We are trying to sort a list. Hover your mouse, and it's saying in the type collections is not applicable for the arguments this. So to get a better idea as to why this is not working, click on this sort method, which, control click it, and it'll take you to the collections class. And notice that there is some generic stuff. This is going to all make sense to you in the next few lessons when we get deeper into generics. But basically, it expects us to implement the comparable interface for the employee class, because we need a way to compare one employee with the next. How can one employee in a list be higher or lower? We need to actually specify what makes one employee greater or smaller than the other, right? As far as sorting in a list goes, we need to specify that in this class. So the way we do that in any user-defined class is we implement, if I get the spelling right, implements comparable interface. And as an argument to the angle brackets, it's going to be employee. All right, so now this class is implementing the comparable interface, so it's bound to implement all of the methods that are specified in the comparable interface. If we click on this comparable guy, it takes us to this comparable interface. And notice all there is in this interface is just one method, compareTo. So any class We went over this in the previous course in Getting Started with Java. Any class that implements an interface must comply with the contract. And here the contract is the compareTo method. Any class that implements a comparable interface must have an implementation for the compareTo method. So that is why right now we have an error. Hover your mouse here and it's saying add unimplemented methods. So let's click here and it overrides the compareTo method. So here's where the magic is going to happen. This is where we specify what makes one employee larger or smaller than the other. So the way Java is going to handle it now is it's going to see the compareTo method in this employee class and compare two employees. One employee is going to be the instance of this class, and the other employee is going to be passed in as an argument to this compareTo method. And this all happens behind the scenes. We don't have to specifically call compareTo method. Java takes care of it for us. We just have to comply with the comparable interface and implement this compareTo method. And in here, all we provide are instructions as to what makes one employee larger than the other. So two employee instances are going to be compared together. One of them is going to be an instance of this class, and the other one is going to be the employee that's passed in to this method. So naturally, we can use these fields to figure out what employee is larger or smaller. Now, this is all subjective. We can sort by alphabetical name, by the department, or naturally, salary seems to be a pretty good candidate. It's a numeric field. We can use that to compare the ordering of employees. So let's go by that. So two employees are going to be compared with each other, their salaries specifically. So this class's instance, right, his salary or her salary, that employee is going to be compared with the employee's salary that's passed in to this method. So we could do if this dot salary is less than the salary of the employee that's passed in. If this is the case, we're going to return -1. Otherwise, else if the employee that belongs to this instance, his salary, if that's greater than the salary of the employee that's passed in that case, we're going to return a +1. Otherwise, we're just going to return a 0. That's in the case where, both of the employee instances have the same salary. Only then would this line be executed. So that's all you really need to do for the compareTo method. You return either a -1 or a +1, and that's the only criteria Java needs to be able to sort your employees. -1 means it's going to be smaller than the employee that's passed in as an argument to this method, and +1 means that this employee, the instance, their salary is going to be larger than the employee that's passed in. And now if we go back to the application, notice that the sort method, there's no error here because this list contains data of type employee, which actually implements the comparable interface, right? Again, if this interface was not being implemented in employee class, this class would not be obligated to implement the compareTo interface. And then the collections method, the sort method, would have no way of trying to figure out what makes one employee larger or smaller than the other. So now that we implemented the compareTo method, it will sort the employees based on their salaries, and it's going to start from the smallest to largest. So let's hit play, and whoops, we forgot one thing. Notice that these are the hash codes of different employees. We want a better reader-friendly representation for employees, so we need to implement the toString method here in the employee class. So right-click, go to Source, and generate toString, and just hit OK. It's going to use those fields, and then when we hit play, notice it presents it in a more reader-friendly fashion. So there we have it. These are the employees. Notice that Angel's salary is only 2,000, so he's first. Then Paul, his salary is 3,000. Mike's salary is 3,500, and Peter's salary is 4,000. And if I wanted to sort it opposite, I could change this to be greater than and less than. I could just make it opposite to what it was. And let's hit play, and notice that now it's sorting largest to smallest. Okay, a lot of people get confused with this negative and positive numbers. What object is coming in and what is it being compared to? But don't worry, sometimes it just takes trial and error. Run your code to see if it's sorting as you expect it to. So there you have it. That's what natural order for employee is in our case. We specified the salary field to be the condition that dictates whether an employee should be on the top or on the bottom of this list. And again, with strings and integers, those are just straightforward. The sort method works on those collections. But when you have user-defined types, you need to implement the comparable interface and specify what makes one instance of an employee or animal or any user-defined type larger or smaller than the other. All right, so a lot of information in this lesson. I recommend you review the information if you're a little shaky on it. Watch the lesson again. Try this out on your own. Practice with the code, and I will see you in the next lesson. Thanks for watching.